Hello, everybody. Welcome to the LoneTeach IT channel. My name is Dharan Kumar. I'm a BTech graduate, civil engineer, and I'm also a student too. I want to share knowledge using this YouTube channel as well as I want to gain knowledge because by sharing knowledge with you, I can automatically gain knowledge and my knowledge gets recycled. So that's the reason why I created this YouTube channel. And I hope you all going to enjoy this the stuff and the knowledge that I'm going to share with you all. And the first thing that I'm going to say is that don't expect me to be perfect because I am also a student. I am learning by myself and trying to teach you all. So please try to understand. And the thing is, I am from India and I am a Telugu student. So don't expect me to speak in Hindi and my English also not that good. So don't expect me to be some kind of professional speaker or anything. I'm trying my best in order to teach you all. So welcome to the LoneTech ID channel. Let's get started. Since we all know recently RRB notification is released, most of you people might apply it to the exam. So I want to teach you all the quantitative aptitude. So let's get started with this subject. And I'm learning it personally by myself and I'm trying to teach you all. So please be patient with me. Please try to understand what I'm going to teach. And I hope you understand what I'm going to teach. Let's get into it. First of all, to learn the max with me, I think it's better for you to learn the squares up to 30, cubes up to 20, and tables up to 20. I think I must insist you to, by heart these three squares up to 30. As you can see, I represented this in the tables below. You can take a screenshot of it so that you can also easily study it. I will try to share my notes when it's almost, when the I will see. I will look into it, but I will try to share my notes if possible because we'll see. And try to learn cubes up to 20. See, since I created a table here, try to take a screenshot of it and try to learn it. Learn not, try to by heart it because it is going to be useful in our future calculations and in your exams. So there you go, the tables 1 to 10, the tables down to 20. I want you to by heart these also because these are going to be very useful in your future calculations and exams too, because to do some faster calculations, I suggest you learn these things. And let's go to the, number system. First, I'm going to start with the number system in the quantitative aptitude. There are several parts in the number system. As you can see, first one is theory, which is mostly consisting of definitions only. I'm going to explain the definitions and also give a practical example, if possible, that I know. Okay. And let's go to unit digits. Unit digit also we have, second part is the unit digit. Third part is remainder theorem. Fourth one is number of zeros. And fifth one is number of factors. First of all, we are going to start with the theory. Numbers, right? What are numbers? A number is a mathematical object used to count and measure. Examples are the natural numbers 1, 2, 3, 4, and so on. As you can see, the number is nothing but a mathematical object which is used for the purpose of counting and measuring. As you can see, let's say we have 5 apples. In order to count those 5 apples, we are going to use numbers 1, 2, 3, 4, 5. 5 apples. Just like that, in order to as you can see, you all have a scale, right? As you can see some measurements on it. We have centimeters on it, 1 centimeter, 2 centimeter, 3 centimeter. In order to measure a line or anything, we are going to use a scale in order to measure the line using the numbers only. Those are nothing but numbers. Simple. It's that simple and easy. Let's get into the real numbers. In order to explain the real number, let me read the definition and I will try to give a practical example of it. All the numbers that can be represented on the number lines are called real numbers, right? Let me show you a practical example. Here we go. Let me draw a line. This is a line. And let us consider a midpoint, which is nothing but an origin. This is origin where the value is 0. And all the values are right side of the origin will be positive, but all the values on the left side of the origin will be negative. Okay. As you can see, I am drawing it. Okay, all the numbers which can be represented on the number line. As you can see, these are all the numbers represented on the number line, right? We can even also include fractions too. As you can see, in between 1 and 2, there will be 1 by 2, right? Yeah, these are all called nothing but real numbers. You can take a screenshot of it if possible, and I will try to give the notes of it. I will try to create or I will try to upload the notes if possible. Please bear with me. Okay, we completed numbers and real numbers. Let's get into the imaginary numbers. An imaginary number is a complex number that can be written as a real number multiplied by the imaginary unit I, which is defined by I square is equal to -1, where I is called an imaginary number. Let's take this one. Since I square is equal to -1, if we were to send the square to other side, is equal to root of -1. Remember this value too. Okay. What he is saying is that let us take an example that we have minus is square root of -4, right? How can we write this? To simply describe this imaginary number is nothing but a real number multiplied by the imaginary unit I, right? Since we have 4, right? Normally, 2 square is equal to 4. Square root of 2 is how much? Square root of 2 is square root of 4 is 2, right? Square root of normally square root of 4 is 2. Okay. Since there will be since in this example, since we are going to since it is -4 and -4, right? If we are going to take the square root of 4 means 2, and there will be left, right? What will be left there? The root of -I. This will be left there. What are we going to do about this? This will be left, right? We are simply going to write this square root of I is equal to square root of -1 as I. I can explain it again if possible. Let me show you again. Let me erase this one because it seems somewhat messy here. Oh, why did I erase it? Yeah, let's take this pen. And since we send a square to the other side, it's going to be minus. Remember this one. This is important. Square root of -4. Let's just say we can even write this as square root of 4 into square root of -1. Right? Square root of 4 is equal to 2 into square root of -1. And we can write it as 2 into, since we already know square root of -1 is I. Therefore, this is nothing but an imaginary number. You understand, right? It is nothing but as you can see, an imaginary number is a complex number that can be written as a real number multiplied with imaginary unit I. Since as you can see, the real number is multiplied with I, with form 2I, it is an imaginary number. That's it. I guess you all understand it. Sorry for trying it so long and trying my best to teach you all. So, yeah. A rational number. A rational number is defined as a number of form P by Q, where P and Q are integers, and Q. Oh, sorry, I think you don't know what this is. And Q. As you can see, these are the examples, right? 2 by 3, okay? 3 by 5. You all say why this one also it is not in the P by Q form, right? Yeah, it is in P by Q form. As you can see, it can be written as 3 by 1. The -7 can be written as -7 by 1. You can written like this. So, yeah. A rational number which is nothing but a number which is in the form of P by Q, where P and Q are integers. Okay, that's it. Irrational numbers. Irrational numbers which cannot be expressed in P by Q form or non-terminating, non-repeating fractions are called irrational number. Yeah. I will give you a practical example of it. Since we know square root of 4 is equal to 2, since the square and root going to get cancelled and we get the value 2. But when it's compared to square root of 2, what is the value of it? Huh? I think it's somewhere around 1.41 and so on. It's not going to end. The fraction is not going to end. So this kind of numbers are called as irrational numbers. And you can take square root of 3 also. It is also going to 1732 somewhere around and goes on, and it will not terminate. The decimal is not going to terminate. Simply non-repeating fractions and non-terminating. Those are nothing but irrational numbers. Okay, let's get into the whole numbers. Whole numbers, the set of numbers that include all natural numbers and the zero. And the number zero is also called non-negative integers. Okay, whole numbers are another name. Don't forget. Whole number can also be called as non-negative integers. There's nothing but you can simply look at the example here. We start with 1, 2, 3, 4, 5, 6, right? Let's take a number line for the example 1, 2, 3, 4, 5. And -1, -2, -3, -4, -5. These are all the numbers leave aside. Starting from here and as the line goes on, these are all nothing but natural numbers. Okay? That is nothing but, whole numbers. Sorry. Whole numbers. Those are nothing but the whole numbers. As you can see, I explained it here, right? Those are nothing but whole numbers. Let's get into the natural number stuff. Natural numbers. All counting numbers are all positive integers. And all counting numbers are all positive integers and natural numbers. You know, if you were to remove, let's take the number line again. 1, 2, again. 2, 3, 4, 5, 6. If you were to remove 0, okay, by keeping the 0 aside, all the numbers which are going to start from the 1 and goes on consecutively, goes on from number 1 to the end. I don't know what's the end that is. Now, from the numbers which start from number 1 and all the positive integers. Positive side numbers are all nothing but natural numbers. Okay? Even numbers. An even number is an integer which is evenly divisible by 2. All the numbers which can be divisible by 2 are nothing but even numbers. Let's take an example. 2 by 2. 2 can be divided by 2, right? So it is an even number. 4 can be divided by 2, right? It is an even number. So since 3 is not 3 is going to be divided by it, but we will get a fraction of it. So it's not going to be an even number. It's going to be an odd number. That is how even numbers are. Odd numbers. An odd number is an integer which is not a multiple of 2. Okay. Simply a reverse of it. 3 by 2. It's not divisible by 3. 3 is not divisible by 2. So it's an odd number. And 5. 5 is not divisible by 2. 7. Not divisible by 2. 9. Not divisible by 2. So these are nothing but odd numbers. Let us give me the example of it. 1, 3, 5, 7, 9, 11. This and so on. These are nothing but odd numbers. Prime numbers. A natural number larger than unity is a prime number if it does not have any other divisors except for unity itself. I guess some of you might get it, some of you might not get it. I also didn't get it until I learned it through a practical example. So I'm going to teach you. What is that is, let's take 1. 1 can be divisible by 1, nothing else. Okay? 1 can only be divisible by 1, nothing else. So it is not a prime number. Let's take, since here in the definition we already gave some examples. See, 2, right? 2 can be divisible by 1. 2 by 1 can 2 times, so we are going to divide it. 2 can also be divisible by 2. 2 by 2, 1. Okay? 2 can also be divisible by 2. Here what the definition is saying, natural number larger than unity, 2 is larger than unity, if it does not have other divisors except for itself, and that means 2 for 2 is the divisor and the unity, 1 is the divisor. It must only have 2 divisors, that is nothing but itself and unity. Is called a prime number. 2 can only be divided by 2 and it can only be divided once. So that's the reason why it is called a prime number. Let us take 3 as an example. 3 can only be divided by itself and it can be divided by 1. So 3 is a prime number. Let's take 5. 5 can only be divided by 5 and it can only be divided by 1. So 5 is a prime number. Those are nothing but prime numbers. Let's take complex numbers. The arithmetic combination of real and imaginary numbers are called complex numbers, right? As you can see, I already explained you all what are the real numbers. All the numbers which are going to be indicated on a number line is called real numbers. So let's take a plus ib. It is an imaginary number and it is a real number, an arithmetic combination. It is an arithmetic combination, right? Let me give you an example. Let's take a as a real number 9 plus, we already did an equation before about square root of -4. As you can see here, this one, 2i. Let's take the 2i. As you can see, this one is a complex number. 9 plus 2i is a complex number. I hope you all get it. It is nothing but a complex number. Remember one thing, you all might think this way. 9 plus 2 I is equal to 11i. It's not possible. Remember this thing. It is not possible. 9 is entirely different. It is a real number. And 2i is an imaginary number. An imaginary number can only do calculations with an imaginary number only. Okay? I hope you all got it. Decimals. A decimal number is a number with a decimal point in it. Yeah, simply, I can only show you examples here. As you can see, 1, after that there is a point, decimal point, and 3, 5. It is nothing but a simple example, a decimal number. And 2.63623 decimal number, and 0.548, etc. decimal number. That's it. That is decimals. Okay. Okay, let's go to the co-prime numbers. The two numbers are co-prime if their highest common factor is 1, or two integers are said to be co-prime, mutually prime or related to prime. Yeah, let me give you an example. Highest, the thing that I understand from it is, in practical manner, 2 can only be divided by 2 and 3 can only be divided by 3, but their highest common factor is 1. 1 is the common. In 2, 1 is common. 3, 1 is common. 4 also 1 is common. 5 also 1 is common. Means 2 can divide it by 1, right? And those are 2. In that way, we can divide it. 3 divided by 1. And another divisor which is nothing but 2, to be precise. And that highest common factor, simply, you can simply understand it. I hope you are getting it. Okay? What I am saying is, 2 can only be divisible by 1 except 2. And 3 can only divide by 1 except 3. So, since as you can see, the common in this is 1. 1 is common in all the co-prime numbers. So, it is co-prime numbers. The highest common factor is 1. We can discuss about HCF and LCFs in future chapters. So, yeah. That's it. You can take it like that. And these two integers are said to be co-prime, mutually prime, or relatively prime. Okay? The other names of the co-prime, I guess, mutually prime or relatively prime. I'm sorry. I also want you to teach me, because I am also at the learning stage. I'm trying my best to teach you all. So, in case if I did any mistakes, I'm sorry. I'm saying it upfront because I don't know how many mistakes I'm going to make. Yeah, composite numbers. It is a natural number that has at least one divisor different from unity and itself. Okay, since we all know prime number has two divisors, unity and itself, like 2. 2 can be divisible by 1 and can be divided by 2. So it has two divisors only. That is nothing but unity and itself. And when it comes to composite numbers, let's take 4. 4 will have, this 4 can be divided by 1, 4 can be divided by 2, and it can also be divided by 4. 4 divided by 1, 4 ones are 4. 2 divided by 4 divided by 2, 2 is 4. 4 divided by 4, 4 ones 4. In that way, itself and it can be divided by unity and the other divisor and itself. It means it must have more than 2 divisors. This is nothing but a composite number. That's it. Let's take 6 as an example. 6, right? 6 can be divided by 1. 6 can be divided by 2. 6 can, 2 3 is, yeah, 6 can be divided by 3. And 6 can be divided by 6. See, it can be divisible by 4 divisors. So, the composite numbers are nothing but having more than 2 divisors, simply. Having at least one divisor different from unity and itself. That's it. That is nothing but a composite number. I hope you all understand it. Let's go to perfect number. A perfect numbering theory, a perfect number is a positive integer. There is an equal to the, that is equal to the sum of positive divisors, excluding the number itself. Example, 6, 28, 496, etc. A perfect number is a positive integer that is equal to the sum of positive divisors, excluding the number itself. Okay, let's take 6. 6 have several factors. It's 1, 6, 1 is a factor for it, 2 is a factor for it, and 3 is a factor for it, and 6 also a factor for it, right? 6 can be divisible by 1, 2, 3, 6. Exclude the number itself. Let's exclude it. Remove it. And that is sum of positive divisors. By doing a sum of it, 1 plus 2 plus 3, we'll get the value of 6. That's the reason why 6 is a perfect number. You understand? Let's take the example of 28. Can be divisible by 1, 2, 4, 7, 14, and 28. Can be divisible by these numbers and have these numbers as the factors for it. Exclude the number itself and do an addition of this 1 plus 2 plus 4 plus 7 plus 14. What do we get? 1 plus 2, 3 plus 4, 7 plus 7, 14 plus 14, 28. That's why 28 is also a perfect number. Now, I guess and I think you understand what is meant by perfect number. Okay? Let's get into the next slide, and you're going to wrap up this chapter by, as this has the last definition, triangular numbers, a number which can be represented. I think it's better to take a laser point when I'm going to showing a number which can be represented as the sum of consecutive natural numbers starting with 1 are called triangular numbers. Okay. Here, must start with 1. Okay. Remember one thing, must start with 1. The sum of the consecutive numbers. Oh, let's take 1. 1 is equal to 1. So that's it. We get 3, right? How did 3 is formed? In this format. 1 plus 2 is equal to 3. 3 is a triangular number. But when it comes to 4, it's not going to be formed from the consecutive natural numbers. Consecutive natural numbers are nothing but, simply those are natural numbers, but side by side numbers. As you can see, these are side by side numbers, right? Beside 1 there is 2, beside 2 there is 3, beside 3 there is 4, like that. The sum of consecutive numbers which is going to be achieved by adding those consecutive numbers, you will get a value which is nothing but a triangular number. That's it. 3 is a triangular number, and why 6 is a triangular number? 1 plus 2 plus 3. 1 plus 2, 3, 3 plus 3, 6. That's right. 10. Why 10 is a triangular number? 1 plus 2 plus 3 plus 4. Okay, 1 plus 2, 3 plus 3, 6. 6 plus 4 is equal to 10. That's why 10 is a triangular number. Okay. I hope you all understand whatever the theory that I taught you today. We are going to continue in the next class, and I hope you all going to like this. And with my heart, I'm saying that I hope you all understand well. And sorry for my terrible English. As you can see, in case if you didn't take any screenshots, take now, here, here. That's it. Okay. I hope you all understand it, and thank you for listening to my class. We'll meet you all in the next class, and I will try to learn it, and I will try to teach.